Hi, good morning, everyone. In this topic, I'll talk about the local storage, focusing on ephemeral storage capacity isolation feature we added in 1.7 and 1.8. First, I'll just give a very quick review of Kubernetes storage. So it could be ephemeral storage or could be persistent storage. For ephemeral storage, normally, a root partition is shared by pods and their containers, including the empty dir volume, which is at pod level, or containers logs, or container writable layer, which is overlay or image. Kubernetes also supports multiple partition. That means you can put overlay, container overlay and image in a second partition. In our feature, we decided only manage the root partition. And so for the rest of the second partition, user need to take care of it. And for persistent storage, it could be a network attached storage or local. Normally, those are dedicated disks. So represented by the volumes concept in the Kubernetes. And so because it's dedicated, so we don't need to care much about the isolation problem. So the goal for this ephemeral storage management, we have management at different layers. For the node layer, so basically what we want to make sure that the node can run stable. So because the system daemons also need to use this. So we want to make sure they have enough space to run stably. So we have a feature called node allocatable. We will talk detail in the later slides. Basically, you can reserve certain amount of local storage for the system daemons. And at the pod level, container level, so we can provide capacity isolation among different pods and containers. So the goal is to avoid like a single container or pod will eat up all the disk space. And also for scheduling purpose, we have the feature called resource request and limit. So by setting up the resource request limit, it helps scheduler to figure out where to allocate to put pods on different nodes. And like CPU and memory, storage also a type of resource can be allocated, consumed. And so for CPU memory, there is also something called storage. Before is more specific for PVC storage. So we add a new API called ephemeral storage. And also add the API for request and limit. And again, here for ephemeral storage isolation, we only manage it on the root partition. And so just as CPU and memory, you can set the limit and request for different type of resources. So after we add ephemeral storage as resource type, so in the pod spec, you can specify the limit and request. And so we need to validate the request is either equal to limit or less than limit. So for request, that means how much storage you want to reserve for this container. And for limit, that means this container cannot use more than that amount of resources. And this is since limit and the request currently only at the container level. So you cannot set pod level resource as request and limit. However, internally, we kind of calculate pod level resource. It is basically just the sum of the resource requests or limits for all the containers inside of this pod. And here, after you set requests and or limits, so it's kind of separate. You can just set requests, or you can just set limit, or you can set both. And after you set that resource, how pod with resource requests are scheduled. So this affects how this pod will be scheduled. The scheduler will check whether each node has enough resource for this pod. And so it won't assign a pod to a node that has does not has enough capacity. And also, we'll talk node allocatable a little bit more, but here you can reserve a certain amount of resources for each node. And so although suppose your node total capacity is, let's say, 10 gigabytes, after you reserve a certain amount of resources for system daemons, you can reserve, for example, 1 gigabytes. So that means the node allocatable is only 9 gigabytes. And the scheduler will make sure the request is less than the allocatable of that node. So that is not the total capacity of that node. It's basically check against the node allocatable. And for a pod with resource limits, for container level, the kubelet will keep monitoring the usage of each container. It will check, for example, the ephemeral storage includes the logs or the root FS of each container, and it checks the usage. If the usage of that container exceeds the limit set in the spec, and the kubelet will terminate that pod so that all the ephemeral storage use will be released. And also for pod level checking, so for pod level, it's not only the sum of container usage, it also includes, let's say, empty dir usage. So it will calculate the total usage for each pod, and it will make sure at pod level, if the total usage exceeds the limit, the pod will be terminated too. This is all by then the Kubernetes Eviction Manager.
So Jing,
yes.
Question there. But you know, the way I'm understanding what you the slide on the one before that.
Yes.
So, are you saying on the last bullet that if a pod
right,
and it goes beyond that, then the pod's evicted?
Yes.
Oh, what? But I mean, it's not really a resource guarantee. Like, you're not guaranteeing that it doesn't consume.
Wouldn't it be better just to constrain it so that the pod can never go over that? Because if it does go over that, it may have some impact on something else before it's evicted, or does the eviction happen like right away?
Yes, eviction kind of, because the monitoring is periodically, right? It's kind of some delay during the monitoring period. So for like CPU memory, we can use C group to limit, so the usage won't go beyond. But for this, we decide it's very hard to just constrain the usage within the limit, and we decide to use eviction method and monitor the usage and evict.
I may be jumping ahead here because I saw something on it, but I mean, couldn't you constrain it with quota, like a file system quota?
So I think there's no like a general way to take care of this in all the systems.
In all the file systems,
yeah.
Okay.
And so we decided not to go that route, at least for now. And this is a simple and effective way of
got it. Okay.
constraint. Yeah.
So kubelet periodically runs du and df on the directory and see.
Yes, so all the metrics comes from C advisor. So it checks
Okay.
the container's usage. Yes. And yes.
Is there a case where the pod might never like get to run stable because on one node, if you have a limit saying don't use to more than 10 gigabytes, and it let's say goes to 10.1 or 10.2, and then you restart that somewhere else, and there it's going to go
Yes,
10.1.
that's possible. That means the user should increase the limit because the limit is not enough for the pod.
Yes, but in traditional Kota-based systems, we don't shut down the app. We say you're going over, throw an alert or send an email or page somebody, but don't bring the database or the app down. And here it might just like kill pods as part of the eviction process. So the app might just go down because it went over quota, and that might not be what people want.
Yes, that's ephemeral storage.
So if we kill it with ephemeral storage, it starts somewhere else. 5 minutes later, it goes over quota.
Start back at that big state, right?
Yeah. So the thing around the app hasn't changed. The universe hasn't changed. So people are using this app or whatever the front end interfaces are, which caused it to go over quota. So the reason that caused it to go over quota, this is an application misconfiguration, sure, that people underestimated. But is evicting the pod like too big of a hammer? And should we? I'm just suggesting that other systems, what they do is they just alert people that you're going above quota, do something, but they keep the app running.
In Kubernetes, there's no such thing as just keeping it alive. You're going to be shut down. Put your storage on ephemeral storage, it's gone. It's okay to shut down and come back up. It's part of the system.
Yeah, yes, it's
like it can be logs or an application just behaving. You do want to do something.
right. Yeah.
System, right? Like at what point do you stop it from killing all the containers on that host?
So Jing read about this one case, and I'll rest my case after I say that case. I said somebody should not use more than 100 megabytes of ephemeral storage. And I scaled out my app, and like this 10 instances running behind the load balancer, and the load just increased. My app goes down because I overblew the quota, because every instance might go down. I'm just concerned if we should do something.
Yes, so because the main goal here is to avoid someone like abuse the disk. So if you don't kill it, right, you just give alert, but it's anyway abuse the whole disk, and other parts may be affected. And this is the main goal. So
related question. Sorry.
And the other thing that we want to do is protect the system daemons. So if there's a pod that is exceeding its limit, it can impact the system and cause the whole node to malfunction.
Hey, this is
So related
Shailesh
question.
from.
yeah, sure.
Let's say I'm a user and I'm aware of this whole eviction strategy. Is there a way to prevent me from setting arbitrarily large amounts for ephemeral storage? Like, is there a way to cap? No user can provision ephemeral storage more than 5 gigabytes.
Yes, so you mean even user doesn't set limit, there is a way to.
Like for an admin, is there a way for an admin
Yeah,
to
so there is a.
enforce nobody?
Yes, there is a called limit range. So it's basically set default value for all the pods in a namespace.
Okay.
So I also have a slide for that. But if all the pods in some namespace and the system admin can decide to create a limit range, that means all the pods in that namespace, even they don't set any limit request, it will have a default value for all the pods.
Okay, and then nobody can go beyond that. If an admin, let's say, I'm not going to allow anyone that namespace to provision more than.
No, no, there's no. So the user can, I think, override that limit. So if you specify limit in your own pod, yeah, it is possible. But there's also quota. So if for each namespace, the system admin have a quota. And if user set a very big limit,
Sure.
and the pod will be rejected because it exceeds the quota. So we have quota to protect that.
And the
yeah.
quotas are applicable to all types of PVs, not just ephemeral ones like the MTDR. But
So for quota, we support PV and also local ephemeral storage, and also some like the number of PVC.
sure, but it's
yeah.
like the aggregate. Let's say the sum of all the MTDR, let's say SCSI, all different types of PVs. The sum, it applies to the sum of all the PVs, different types of PVs that a user may use, right?
Yeah, so there are different settings. So for PVC, you kind of specify a size, right? So you can have a quota for PVC. The sum of the PVC will be limited by that size. And then you have local ephemeral storage quota. And then it will check. Here, you can only set limit and request in the container spec. So it will check in the container spec whether the sum of all the containers, right, exceed the quota in that namespace.
I have
so
a question.
It check different quota. We have CPU quota, we have memory quota, we have PVC size quota, and we have local ephemeral storage quota. And also we have a few others, like counts the number of PVCs. Yeah, storage class also has quota. So that means in that specific storage class, you cannot request more than this much.
Okay.
Yeah.
So you're right, it's not broken down.
Can you guys hear us on the phone?
No, we can't hear you on Hangout.
Okay, so I have a question here.
So they can
you guys-
hear us?
Can you?
Oh, okay.
Yeah, we can hear you.
All right. So question is this Kota applicable?
So for this, let's explain the node allocatable concept. So at node level, each node has a capacity of different type of resource, like CPU, memory, and we add local ephemeral storage too. And you can reserve the resources for system daemons by just putting this a flag called kube reserved or system reserved. So for CPU, memory, and also ephemeral storage, you can reserve certain amount. And the Kubernetes will calculate the allocatable, which is the capacity minus the reserved resources. So the allocatable amount will be used and during the scheduler, like check whether a pod can be assigned to a node, and depending on the resource request, it check against the allocatable. And also, allocatable will be in the eviction manager, so it will make sure all the pod usage, including everything, like say the local ephemeral storage, like logs, containers, overlay, and the MTDR, right? All those usage should not exceed the allocatable. So that means the reserved part of the resources should not be used by users' pods. So to make sure the system have enough resources. Yes.
So what risks is Kilo considering when you're specifying
The root partition, root file system.
So it's not strictly out of like the Docker graph or we're talking out of.
Yes, right.
You have a couple of questions.
So a couple questions from people on the video conference. Question from Chakri is, how does it work with pod taints and tolerations?
With pod taint and tolerations. So it means when the pod or node, he means the pod toleration or node toleration.
Chakri, could you clarify? Let me see if we could get the audio working so he can talk. Someone on the video conference speak? Just say testing again and again.
Testing. Are you able to hear us?
Okay, we can't hear you yet, so let me switch
This
to
is
a
Jeff.
different
Testing.
device. Can you try speaking now?
Testing. Testing.
Nope, still can't hear you. Let's do one more. All right, try that.
Testing.
Can someone say something?
Testing.
Testing. Testing.
Are you guys talking? So,
Test, test,
let's
test, test.
see. Volume is at full max. If you're on the video conference, just keep blabbing until I tell you to stop.
Okay. Yeah, this is weird because we hear each
Okay,
other.
so it sounds like it's just a matter of getting our speakers out here.
Okay. Are you able to hear us now?
Is that working? Anybody?
Testing. Testing.
Yes. Testing.
No, it is not working, I guess.
Okay, we'll see if we could get somebody to take a look at this. In the meantime, I'm going to hand it off to Michelle to proxy the questions.
Hold on, I'm not on the Hangouts chat. Is someone on the Hangouts chat that has access to the questions?
Testing.
For Kota is not the actual. So I think I have a slide for Kota if someone asks about Kota. So I just explain Kota a little bit and then we can answer the question. So for Kota, it works on namespace level. So normally when there's multiple teams working together and the system admin can separate them into different namespaces. And so we provide the Kota concept at namespace level. So if there is a Kota object created in that namespace, that means it gives a constraint that limit all the aggregate resource consumption per that namespace. And for example, in the Kota object, you can set the request Kota. You can also set limit Kota, or you can set both. For resource request Kota, that is the sum of all the requests that cannot exceed that value. And similarly, for limits, that means the sum of the limits from all the pods cannot exceed that Kota value. And during the pod creation, and the Kota will be validated or checked against each pod request or limit. So for the reserved, yes, you can reserve some amount of resources, and then the node capacity becomes smaller. So because some resources basically you reserve for the system and no user's pod can use that, so the capacity basically becomes smaller. We call it allocatable. And so when pod is created, the scheduler will check whether the request can be satisfied by the allocatable resources. And Kota is separate from node allocatable actually. So the system mean can set a Kota actually exceed the node capacity. So that means you might have overcommit. But it depends on system mean, and they can set Kota basically less or equal than the node capacity. And the Kota will be checked against the request limit too.
Let me just take an example. Like let's say I have a Kubernetes cluster across all nodes. I have let's say 100 GB of
Yes.
Okay.
Yes.
So that, and when I'm creating the namespace, I can say I want to give 20 gigabytes.
Yes.
One.
Right.
That is the quota.
That is quota, yeah.
Right. And inside this namespace, you can also specify the pod level resource allocation, like request and pod level.
For each pod, actually you specify in the container level, but it's okay. It's just kind of in each pod spec, you can specify request limit. Yes.
And can you also do it at the node level?
No.
No, only at the pod.
Yeah. Yes. So in the pod spec, you can give a request or a limit for how much resources you want to give for this pod. And it will check against the quota, but this quota is namespace level, right? So it makes sure it won't exceed. So all the pods, requests, and limits will not exceed this namespace quota. And also when scheduler schedule the pod to each node, it needs to decide which node it can schedule the pod. Then it will check whether the capacity of that node, we call it allocatable, can satisfy the pod request. So it's different checking. One is check the quota is satisfied at namespace level. So for namespace level, right, is basically all the pods in that namespace will be checked. So as long as the total request limit can be satisfied by the namespace quota. Yeah.
So other than ephemeral storage, we also have persistent storage, right?
Yes.
So this quota is going to be for both ephemeral and.
Not for you specify different quota. Yes, it's not one single value. So you said one is for ephemeral storage quota and one is for, let's say, persistent volume size quota. Yes, those are two different values.
Okay, so question from the chat from Shailesh is, how about the resource limits? Are they on actual usage or on provision capacity against containers?
How about the limits, right? So, but which limit he's talking about? So, yes. Can you repeat the question again? Yeah.
How about the resource limits?
Yeah, and the whole question
Are
is,
they on actual usage or on provision capacity against containers?
So here, right, we have different kind of checking. So after the pod is scheduled on a node, right, you set the limit for that pod. And the actual usage, we monitor the actual usage of that pod. And if the actual usage exceeds the limit you set for this pod, and we take action like eviction, right, evict the pod. And this limit might also be checked against the quota if you have a quota set for that namespace. Or that limit can be also checked against during the scheduling, right? Check against, no, for scheduling, limit doesn't matter, yes.
And yeah, this is, to clarify, this is for ephemeral storage. In
yes.
addition to CPU and memory.
Yes, CPU memory is similar.
Okay. And the second question is from Chakri. How does this work with node tolerations and pod taint? No, I think it's the other way around. Node taints and pod tolerations.
So I don't think it's whether if the node taint, I don't think pod can be scheduled on that node, right? So, but for pod taint, I'm not very sure about.
I think Chakri's question is, when we choose to evict a pod because they exceeded their limit,
yes.
Do we consider if the pod tolerates or not tolerates a taint? I think it's independent.
Yes, we don't evict, for example, the critical pod or non-static pod, but for the rest, we don't consider like pod taint or not if there is such, and we just monitoring the usage and check the limit, and we'll decide just evict, yeah, except the critical and the static pods.
Yeah, so I think to answer Chakri's question, the pod taints and tolerations is considered independently from the resource limits and requests.
Right. It's they are not like have affected with each other. Yeah. And for limit range is another concept for namespace. For system in, it's easier for system in because once you have a quota created for that namespace, that means all the pods in that namespace must have a request or limit. So if a user have a pod spec that does not specify limit or request, it will be rejected. So it's easier for system in just give a default value. So user don't need to worry about setting this value. And this is the concept of limit range. And this is also an API object. If you create limit range API object in that namespace, you can set default value for different type of resources. So for CPU or memory or ephemeral storage, you can set default value. And for any user's pod, if they don't set a value, the default value will be applied. Actually, I missed one slide. Basically, it's related to empty dir. So in 1.7, we also add a feature, and you can put a size limit for empty dir, just similar to containers limit. So, so when user's pod is running, Kubernetes will check the empty dir usage, and if the usage exceeds the size limit you put in the pod spec, similarly the pod will be evicted. So to make sure the empty dir won't use a lot of disk resource. Any questions? So in the future, we plan to continue some of the work related to the resource management, storage resource management. For example, we can expose the local ephemeral storage usage through the kubectl top. Right now, kubectl top only shows CPU memory, and it will be convenient for user to get also local ephemeral storage usage through that way. And we can extend metrics API to local to include the local storage usage. And node problem detector, it is a feature that it can automatically monitoring and detect depending on which kind of problem you want to detect. So we can expose the partition failures or disk out of disk usage through the node problem detector. And also disk IO isolation. Currently, all the work is related to like capacity isolation, but for IO isolation, we want to address, but it's kind of a challenging problem. We'll work in the future, yes. Yes.
Jing, thanks. So I just wanted to, first I'll preface this, which is I'm raising an issue without proposing. I don't have a proposed solution, but think when you look at like expectations, right? So like if I write an app and in my pod definition, I say, you know, what amount of CPU I need, what amount of memory I need, what amount of ephemeral storage I need, and it gets scheduled.
Yes.
Then my expectation is, you know, I'm confined to that, but in at least my understanding, if I can't physically exceed my memory or CPU, and so there's no eviction that takes place in that scenario, and so like
application could go bananas and start using more than what it needs.
No, but I don't get evicted. My application just breaks or something, right? Like you know, like I run out of memory, maybe my application stops responding or something like that. But in the case of storage, I actually get evicted. And so I may have been, you know, using my ephemeral storage for, yes, it's temporary scratch space, but it was germane to my application. And so like as far as like how I'd code the application, I would plan differently for managing memory and CPU than I would for storage. Like, I'm just saying, I think it's going to catch a lot of folks off guard just to get straight up evicted. No, I get that. It's different though. Like I could put in stuff like that says, look, if I'm starting to run out of memory, do this in my application. If I'm starting to run out of CPU processing or latency, do this in my application. You get no such feedback on the ephemeral stuff.
The eviction manager will kill your application for overuse of memory or CPU as well.
So, if you're an XED cluster and you 5 nodes all in ephemeral, one shuts down, you come off and you know what you're saying. You lose data.
Yeah.
You lose the scratch space. Yeah.
All 5 nodes can go down at the same time. This is ephemeral.
It's a different thing.
That's what I'm saying. So I get what Steve's saying. But what you do to solve that is give it a specific name. So don't use the existing Kota that we use already for CPU and memory, for example. Can you repeat that?
So the way to get around some of this might be to actually just use a specific term that says, disk usage termination level or something like that, to make it very clear to users and admins and everything else that if you exceed this limit, it's going to actually kick this out, right?
Yes. So actually, for memory, I think it's also so the limit by definition, right? So here we don't want to use more than that limit, and so the pod will be terminated no matter what type of resource it is.
Yeah, that's fine.
For memory, it also
maybe I had a misunderstanding of how it works today. So actually, if you exceed CPU or memory today, you get evicted
actually
as well?
For CPU, it is, but for memory, you will be terminated too.
For memory, okay.
Yes.
All right.
For CPU, you can kind of just constrain the CPU and the application is still working. But for like disk IO usage, right, if you constrain, the application might just not working at all. Instead, we can evict. That means we kill it gracefully, and then we start somewhere else. So it won't cause a problem like the application just kind of freeze or will not run at all. Instead of
it's the same experience then, which is more of a user experience of setting expectations question that I'm bringing up.
Right.
So ephemeral. I think there might be a difference of how people see ephemeral versus outside this group. Exactly the example you specified. One node and one pod having ephemeral is different from your application being ephemeral. If you take a 5-node cluster, the reason some people might put ephemeral on their etcd stores is because they think, I have 5 of these. So all 5 are not going to die. 2 can die, they'll come up, they'll sync. But these things, based on application load or something, have the possibility, rare, but kill 5 nodes. And now that is data loss. That was what.
But that's the Kubernetes model, right? Or working with containers, right? Containers are always ephemeral. That's the shift that you have to make.
But containers don't have state. Yeah.
If you're going to use ephemeral storage, you're going to take that risk. Right. If you actually want to save your data, do not write in.
That's the whole point.
So good luck convincing customers that way, because people don't look at. I'm just taking feedback from what I hear.
You're in the perfect position, right? Then for those customers, you say, yeah, this is why we have persistent storage, and this is why you want to use it.
There's a.
I think most people use ephemeral storage as a customer to save on money, to be able to not pay for persistent storage. I think what we need to do is show them that containers are not VMs. And in VMs, you could possibly get away with doing that by using the ephemeral storage on your VM on OpenStack or AWS. But this is not the same world, and I think it is our duty to train and teach and show the customers that your model of using ephemeral storage is not the same. Even though it has the same word, it is not the same. And we should encourage them to use persistent storage instead for those applications.
Just a counterpoint.
It's actually not
like,
that different.
Yeah.
In OpenStack, it's
So if the application is very critical, you can also like don't give a very low limit or don't set the limit to avoid like eviction action. So yeah, I think the discussion. Thank you for all the discussion. It's very like useful. Yeah.
Yeah, but okay, so here's a real world example, right? So people running the Hadoop distributed file system in Amazon, okay? What people would do is provision a large boot disk and then Hughes wanted like a directory off the root partition as a data directory, right? So they're getting local IO, right? And it's not an EBS attached disk. It's done for performance reasons. Yes, they know it's ephemeral, but there's an expectation that the actual platform will replicate the data. So there's some expectation that, yes, it's ephemeral, but I'm protected because I'm just playing the game of like, I have more replicas than I'll have down nodes. So, and so, yes, I see Luis's point about like, look, this is containers. Things are a little more loosey-goosey in nature. But I think like the expectation is, look, if I start a container, like it should stay running on the node, barring like some bad thing happening, right?
So, and for your use case, you should be using local persistent storage.
Exactly. Yeah, you should.
If you need your storage to be persistent, whether it's local or not, you should be using persistent storage. If you're using ephemeral storage, you have no guarantees to the lifespan of that.
So I think it's just like,
So it will never be persistent.
so I don't want it to be persisted. I just,
Yeah, but if you're creating data through, if you're processing or creating data through HDFS or whatever, you're obviously wanting to do something with that data long term. And if it's all ephemeral, even if it's across 6 nodes, any one of if you have a complete failure, you lose everything. So unless you're doing streaming analytics where you're processing results in real time and writing them to somewhere persistent, I wouldn't even see why you would use ephemeral for HDFS. You would use local persistent disk.
Yeah, even systems like etcd where you need a majority of nodes up, like systems like etcd, you need a quorum up, which is like more than 3 replicas in HDFS. You know, even their recommendation for having a production etcd cluster is to use persistent volumes.
It just because people do it, and I'm not disagreeing that you have pointed out a perfect use case, it doesn't mean it's right.
I think as long as it's clear to the users why their pod was terminated,
yes,
we should be fine. You know, as long as they know the reason their pod restarted.
Yes. Sure. Yeah. I mean, the user has to have a right expectation that it isn't going to be up for 5 seconds and then it's going to be dead because I've reached the limit. So I agree with that.
So ephemeral versus persistent storage aside, this design does something so the expectation is that I have 10 nodes in my cluster, and the failure of the nodes are not correlated. For some reasons, one node might be down. For a different reason, something else might be down. But now, because of an application constraint or some limit being passed, all my nodes where my app is running are unreliable, and this is like a correlated failure. So
yeah, this feature is
it takes me closer to my app going down than it was earlier.
Okay, but let's consider the not so honest ramifications of not having this. So if I don't have this, I can also build an application that's absolutely going to take my entire cluster down because I don't have any constraints around that.
I agree with the problem of the abuse and the applications going haywire.
Yeah.
But I think the policy should allow that, like, for example, if I'm using a 5-node etcd cluster, put a hard limit on all of those, but don't kill more than 2 at a time, or keep at least 1 alive, even if it bursts and goes haywire on 1 node. Because allow me to choose my SLA.
Someone mentioned VM versus containers, which I think is a relevant point because we're no longer in a world where all that's running on this
ephemeral storage and node is one application.
Microphone.
But other pods and other applications running. So we're concerned too much about this app dying. What about all the harm it's doing to everything else running on these nodes?
But that's the cluster admin's problem and resource management and stuff. But if there is an SLA for you to say that I'm scaling out your app for availability and things like that, and for a single 10-second burst, if all nodes go, all my pods are killed,
Right.
that's a violation. I
agree,
can't
but
uphold
then
that
you're
SLA.
also violating all the other 9 applications because they may go down because you've chewed up all the ephemeral storage.
But
right,
you,
so
you don't want to punish app developers so much just because of an SLA violation. I'm just saying, give me an escape hatch which says it's okay to burst in some specific.
Yeah, you can only set requests. You don't need to set limit. So you can, depending on your application, you can give different options like what you want to set. Yeah.
And also Jing mentioned that you can set your pod as a critical pod. And in that case, it won't be affected.
Yes, so there are different options. So it's not, you must set a limit or, yes.
And there's only so much you can do to protect a user from themselves. I mean, you can't engineer a system that someone can't misuse. And I think if you do have a user that says, we're going to use ephemeral storage, we're going to have 10 node replicas, I think that it's on them to understand the risk that if every node goes down, which is completely within the realm of possibility, they understand that and they have some kind of plan in place to deal with that. I don't think I mean, there's no engineer in the world that can design a system that can thwart every user's misconfiguration. You know, if you're using ephemeral storage, you have to understand that it's not persistent by definition.
Yeah. Thank you for the discussion. Yes. So basically, this is like we provide all these features for system in, like for users to like flexibility, very flexible, like configure their applications and systems. And so it's true, like system admin probably need to figure out how to set for their environment. And also users need to understand and what's the meaning of each value like they set. So any other questions related to, yeah. Yes.
Is this informational just to catch us up, or is there something you wanted to get agreement on?
So I think I want to also like get some feedback related to this feature, and also what else we missing related to the storage resource management. This is what currently we offer, and this is some of the plan, and anything we are missing, and you see like from your experiences, so how to manage like storage resource management, and we can help like.
So I don't have solutions for the problem that I'm posing because it's a hard problem.
Sure.
All these requests and limits are based on capacity, right?
Yes.
Use 10 gigs, 50 gigs. There's also a performance aspect to storage when it comes to like multiple containers running on the same node.
Yes.
If there is a possibility, or even if you have the bandwidth to think about like this pod shouldn't do more than 300 IOPS.
Yes.
Or this pod should not be allowed more than 1,000 IOPS or
right,
something.
that definitely.
It's not easy. But
yes, it's definitely in the roadmap related to this like I/O contention, isolation. So we plan to work on it. It's just it's challenging, and we want to gather all the ideas and how we can work on this. Yeah.
We know what the status is of the Linux kernel for providing that, because that's a C group implementation. Right?
C groups have the capabilities. Yeah.
I'm not an expert on any of that, but from what I heard from Fish, I think there were issues with this I/O isolation.
By C groups at the moment.
So it's not like perfect. Even you have the capability.
So yeah, C groups are a very good mechanism if they work, but we could do C advisor like thing saying it won't be that instantaneous, It might burst like 300 goes to 600 IOPS, but if we detect it even with some latency and are able to feedback, most people don't know what their apps are doing. This is my experience.
And also based on the knowledge that we learned from Fish, the C groups IO isolation totally fails for SSDs because SSDs are just way too fast. And the queuing that C groups adds actually lowers the performance of SSDs.
Yeah. So for persistent, because we basically, in most of the cases, is dedicated disk. So you are not going to have multiple pods using the same volume, persistent disk. And they are not sharing, right? You don't need to isolate among different, and there's Kota available for persistent storage if you want to limit how much resources for each namespace. Yeah. And but for isolation purpose, we don't have anything for that because normally persistent disk is not shared by different pods.
So the non-ephemeral storage, I assume is what you're referring to, like here. If you had, like, if the use case was, hey, I've got Cassandra, and you're saying I don't want to use ephemeral storage, you'd say, I want to use possibly data in there. One of the volume types is actually local. You still would want to isolate that from a performance perspective from other.
So MTDR, we do have a size limit, so you can specify a limit specifically for MTDR.
Like performance, so like the limitations that you had up here for this kind of isolation.
Oh,
like
for yeah.
Local volume objects as well, right?
Yes, yes. Okay, thank you very much for all the feedback discussion, and so we can, if anyone interested, we can talk offline.
All right, thanks, Jing. So next we're going to take a 15-minute break while you sort out technical issues, and we'll resume after that.